Namaste children. So good morning to all of you and welcome to today's maths class. So today I am going to introduce probability chapter, 15th chapter. So you are already familiar with this chapter about this concept of probability in class 7th and class 8th in data handling concept, data handling chapter. So in addition to that, what we studied in class 7th and 8th, what we are going to study in this class 9th, it is almost what we have covered there, the same thing will be there, we are going to study. But in class 9th, we are going to study about the experimental probability or empirical probability. Class 9th, the 10th also to be continued, the same chapter name probability. 15th chapter, they will study theoretical approach, theoretical probability. What is the difference between empirical probability or the experimental probability and theoretical probability? We will study in class 10th. Now you see here some of the statements are there on the board, like in everyday life we come across statements such as it will probably rain today. It will probably rain today. It means it may rain or it may not rain. Then I doubt that he will pass the test. So here the word doubt will give you a cause for the uncertainty. Uncertainty means it may happen or may not happen. So he may pass or he may not pass. So most probably Kavita will stand first in the annual examination. So here one more word, most probably, doubt in the second statement, probably in the first statement. All these statements will reflect the uncertainty, an element of uncertainty. So most probably Kavita will stand first in the annual examination. It means again there is a chance, she may be the first in the annual examination or she may not. Similarly, chances are high that the prices of diesel will go up. Nowadays we are finding every day the diesel or the petrol fuel rates are increasing day by day. So there are chances are high. It means that compulsory the prices of diesel will increase. So there is also a probable a chance of increase or decrease. So here chances. Now the words probably, doubt, most probably, chances, etc. used in the statements above involve an element of uncertainty. Uncertainty means what? Having both the chances may happen or may not happen. So now this uncertainty of probably, etc. can be used, can be measured numerically by means of probability. So this uncertainty which is happen or which cannot be happened, which may not be happened, is measured numerically by using a special branch of mathematics, that is probability. This probability, so it is started with the concept of gambling, then it is applicable or used immensely, extensively in the fields of science like physical science, biological science, medical science and commerce. So this probability is using in many fields of science nowadays. Now this is about the introduction of the probability. Now we are going to discuss what is an activity. We will discuss how to find the probability, what is the probability. Then we will come to the probability formula, we will formulate the probability. Yes, is it clear? Now I will explain the probability and experimental approach. As I said that earlier, here in class 9 we are going to discuss about the experimental probability or empirical probability with an activity. Activity is tossing a coin. Yes, you might have seen the coin. It has both a head and tail. So when we toss a coin, tossing a coin, it is an activity, it is an experiment. We are doing an activity. So here the tossing a coin is an experiment. When we toss a coin, what are the results which we get, or what are the results, or what are the outcomes which we get? Yes, most probably yes, the head and tail. When we toss a coin, what we get? It is head or a tail we get. Head or a tail. Head will represent with H and tail will represent with T. So here we have two chances are there. One is head, the other one is a tail. When we toss a coin like this, if you do an activity, then if it is then how many chances are there for getting a head? It is only one chance. For getting a tail, it is only one chance when we toss a coin once. Total number of all possible outcomes or all possible chances, how many are there? Two, head and tail. Head and tail. So now here, so now take a toss, take a coin and toss it for 10 times and find out and write the results and the outcomes which you got. Then write them in the linearly or horizontally. Then you locate them in the table. So you replace them in the table. Yes, when you toss a coin 10 times, like for suppose if you toss a coin, first trial we got head, and second trial also we may get head, third trial it is tail, fourth trial it is tail, and fifth it is head. When we toss again the sixth time, it is maybe head, tail, or the seventh it is head. When we toss the eighth time, it is a tail, or when we toss the ninth time, it is tail. Even the 10th time also we got tail. Like this, you write all the chances which you got when we toss a coin for 10 times. Then write number of times head comes up. How many times you got head? Count from this and you write 1, 2, 3. Yes, 3 times we got head. Write 3 in the table. Then number of times a tail comes up. Number of times a tail comes up. How many times is there tail? 1, 2, 3, 4, 5, 6 and 7. 7 times we got a tail and 3 times we got a tail. So total how many times you toss the coin? It is 10 times. So how many possible outcomes we get? 10 possible outcomes. In that 3 are it represents head and 7 represents the tail. Now find out these fractions. That is the first one. Number of times a head comes up to the total number of times the coin is tossed. So how many times the head comes up in this 10 times when we toss it is 3. So 3 divided by total number of times the coin is tossed. How many times we toss the coin? Yes, it is 10 times. Therefore it is 3 by 10. 3 by 10, which is equals to 0.3 in the decimals. Next second fraction is number of times a tail comes up divided by total number of times the coin is tossed. So how many times we got tail? It is 7 times. Therefore it is 7 divided by total number of times the coin is tossed. It is 10. So what we get is 0.7. Now you have tried one more time. 10 times again you have tossed. 10 times again you have tossed. Now when we toss it 10 times, second time we got like this. The outcomes head, tail, head, tail, and head. See how many we got here? 4 and 8. Now you see here tail and head. You see when we toss here, suppose yes, this is also tail. Now you list out them after tossing the coin for 10 times and write the number of times head comes up. Count how many times you got head. 1, 2, 3 and 4. Then tail, how many times we got? It is 6 times. It's not 1, 2, 3, 4, 5 and 6. Now write its fraction. Yes, the first one. Number of times the head comes up is 4 times. Total number of times the coin is tossed is 10 times. Therefore it is 4 by 10, which is equals to 0.4. Next, the number of times the tail comes up That is 6 divided by total number of times the coin is tossed is 10. 6 by 10 it is 0.6. Like this, if you continue the again next time 10 times if you do, we will reach these fractions. We will reach these fractions to the nearer to the 0.5, nearer and nearer to 0.5. That is, this fraction is 0.5 and the second fraction is also nearer to 0.5. Clear? This is an activity. This is an individual activity. Now you can also do group activity also by two children together. That is, instead of 10 times, you may toss 20 times or 40 times, 100 times. Like this, and one student will toss the coin, the other student will know, he will note down all the results and he will make a table. In that table he will write all this, how many times we got head and how many times we got tail comes up, how many times that he will write, and then he will find out all these fractions. If you do like this at 20 times, 40 times, 60 times or 100 times, like this if you do, in that case also will come to 0.5 and 0.5. It is very nearer to this value we will find out. So we can conclude that as when we toss a coin, we have only two chances, head and tail. So head comes up is nearer to 0.5 and the tail comes up is nearer to 0.5 when we toss many times. Many times. Is it clear, children? Yes. Now here I wrote here two fractions. This fraction represents probability. Now we will discuss in detail how to find the probability. Is it clear activity? Yes. Now we will discuss one more activity about a die. Yes, you have seen the die. It is in the cube shape and it has 6 faces are there. So on those 6 faces we will find numbers. On each face we will find one number, that is 1 to 6 we will find 1, 2, 3, 4, 5, 6. 6 faces, 6 numbers. Sometimes we will find dots on the die. One dot, 2 dots on the second face. Third face we will find 3 dots. Fourth face we will find 4 dots. So on, so like 6th face we find 6 dots. So when we throw a die or when we roll a die, what are all possible outcomes which we get? Yes, the numbers 1, 2, 3, 4, 5, 6. So when we roll a die once or when we throw a die once, we may get 1 or 2 or 3 or 4 or 5 or 6. Like this. If we throw this die 20 times, how many times? 20 times. And note down those results which we got for these 20 times when we throw a die results. Then you note down, like when we throw, first time we got 1, second time when we throw it we got some 3, third time when we throw we got some 4, or fourth time when we roll it we got 6, then again we got 1. Like this we got 20 times when we throw, we will get 20 results. Those 20 results you make a note, and then from those 20 results fill this table number of times these scores turned up. Here scores in the sense numbers. How many times 1 is turned up, how many times 2 is turned up, how many times 3 is turned up, or how many times 4 is turned, how many times 5 is turned, or how many times 6 is turned up. For example, 1 came 3 times and 2 came 4 times, then 3 came only 1 time, 4 came some 5 times, like this, then 5 came 5 times, and 6 came, it is 2 times, total 20 times when we throw a die. These are the results. That is, number 1 we got 3 times, and number 2 we got 4 times, number 3 we got 1 time, number 4 we got 5 times, and number 5 we got 5 times, and number 6 we got 2 times. Total 20 toss, 20 throws we had. Now find these fractions. Number of times 1 turned up to the total number of times a die is thrown. So how many times we got 1? It is 3 times we got 1. 3 divided by total number of times. Total number of times the die is thrown. How many times is 3 by 20. 3 by 20. Similarly, so when we find this to the decimal form, what we get is 2 tens are 20, 2 ones are 0.5, 2 ones are 2, 3 minus 2 is 1, keep point and bring 0, 10, 2 5s are there, 1.5, then divide with the 10, so what we get? 0.15 we get. Or you keep in the fractional form only, that is 3 by 20 we got here for this fraction. Then second one, number of times 2 turns up. 2 how many times we got? 4. 4 divided by 20. Then third one, number of times 3 turn up. 3 how many times? Only one time. That is 1 divided by 20. 1 divided by 20. Next, similarly we will find for number of times 4 turn up to the total number of times a die is thrown, that is 5 divided by 20 we get. 5 divided by 20. And 5 comes up, it is 5 times. Again this is 5 divided by 20. Similarly, number of times 6 turn up, it is how many times we get, total number of times a die is thrown is it is 2 times only 6 we got. 2 divided by 20. So when we simplify this, what we get? 2 ones are 2 tens are 1 by 10. And this is 5 ones are 5 fours are 20. It is 1 by 4 we get. This is also 5 ones are 5 fours are, we get 1 by 4 on simplification. So all these values are lies between 0 and 1. These values are lies between 0 and 1. Now, if we increase the number of times throwing a die or rolling a die from 20 to 40, 60, 100, 500 like this, we will observe these fractions, that is what we got, 3 by 20, 4 by 20, 5 by 20 and 2 by 20, all these things, whatever we got, they reaches to nearer and nearer to 1 by 6, 1 over 6. That is one number of times, that is number of times 1 turn up to the total number of times a die is thrown is 1 by 6. Similarly for 2 also 1 by 6, and for 3 it is 1 by 6, and for 4 it is also 1 by 6. Similarly for 5 1 by 6, and for 6 is also 1 by 6. Means these fractions will come to nearer and nearer to 1 over 6 as the number of times we increase throwing a die. So it means all they will have the equal chances, because when we throw a die we have only 6 possible outcomes are there, that is 1 to 6 we get. So each one will have the same fraction of 1 by 6, 1 by 6, 1 by 6, 1 by 6 and so on. It is 1 by 6 only for all the 6 times. That too it is a nearer value, not exact value. This is an experimental approach. So like this we will find these fractions, and these fractions we call them as what? A probability. So here we have taken one die. We also can do this activity by taking through 2 dice and 2 coins. 2 dice and 2 coins, and we can tabulate these values like this, and we can find those fractions. Is it clear, children? With this here some terms are there. This throwing a die or tossing a coin is called an experiment. The results which we got 1, 2, 3, 4, 5, 6, all these are called outcomes. They are called outcomes. Throwing a die is an action. This is an experiment. Getting 1 or turning up of 2 or getting 3 or getting 4, all these are what they are called the events. They are called events. When we toss a coin, getting head or getting tail, those are known as trails. They are known as trails. And how many times we get head or how many times we get tail, that will represent number of favorable outcomes of that particular event, of that particular trail for the tossing a coin. And event will call for what it is a die. For a die we call it as an event. Like this, some terminology is there. The terminology we will discuss now. Yes, here is some terminology related to probability. That is experiments. Already we have come across tossing a coin, throwing a die, or some of the examples of experiments. Trial. It is an action which results in one or several outcomes. Trial is, that is, tossing a coin is a trial, but just each toss of a coin is one trial. Each throw of a die is one trial, or taking out one card from a deck of 52 cards, playing cards, is also a trial. So trial is having only one action. It is an action, only one action. Whereas experiment will have tossing a coin means what it is. When we toss a coin, we get what? A tail or a head. Two things are there. But here, each toss of a coin is one tail. That is, tossing a coin, we get head is one tail. We get a tail, head is also one trail. Each throw of a die is also an example for trail. Events. Getting a head, when you toss a coin, this is getting a head or getting a tail is an example of event. Getting 1, getting 2, getting 3, getting 4, getting 5, 6. When we throw a die, when you play with a die, all those are known as events. Possible outcomes. All outcomes of an experiment. All outcomes of an experiment. All outcomes of an experiment are known as possible outcomes. If we list them, listing all possible outcomes of an experiment is known as sample space, and it is denoted with yes. So yes represents sample space. It includes all outcomes of a particular experiment. Now, favorable outcomes. All outcomes of a particular event. For example, getting a head. So getting a head is an event. How many outcomes are possible for this? That will represent favorable outcome of getting a head, favorable outcome of getting a tail, favorable outcomes of getting one. That is favorable outcomes. So, and along with this we have that is a certain event or sure event. Certain event or sure event is an event which must happen. Such events are known as sure events or certain events. Then the other one, it is impossible event. The events which cannot happen are known as impossible events. The events which cannot happen are known as impossible events. Yes, this is now with this terminology you will write a formula to find the experimental probability. Is it clear, children? Yes. Yes. Now, the experimental or the empirical probability is defined as the ratio of number of favorable outcomes of an event, to the total number of possible outcomes of an experiment. Here, this includes this experiments contains one or more than I told you. They contain one or several experiments. Several events will be there. So if you take one particular event, how many favorable outcomes are there to that particular event? To the total number of possible outcomes of an experiment will give you probability. Yes, let E is an event. Let E is an event. Then symbolically we will write this as let E is an event. P of E, probability of an event E is equals to P of E means probability of an event E is equals to total number of favorable outcomes is represented with N of E, where N represents number of favorable outcomes of an event E. Number of favorable outcomes of an event E divided by total number of all possible outcomes of an experiment, that is N of S, where S stands for sample space. This sample space contains all possible outcomes of that experiment. That is total number of possible outcomes. And this is number of favorable outcomes of an event E. This people write this formula symbolically as P of E is equals to N of E divided by N of S. Simple formula we can write in the symbolically, right? Now, as I told, when we find the probabilities of an event, where it lies, the probability of an event, the probability of an event is, it is either greater than or equal to 0, greater than or equal to 0, that is P of E greater than or equal to 0, and less than or equal to 1. Less than or equal to 1, it means P of probability of any event may be 0 or maybe 1, or in between 0 and 1 also will take. That is, it is never negative and it is never more than 1. That is, it will not take any improper fraction or mixed fractions. It will take only what it is proper fractions, and it also takes the value of 0 and it also takes the value of 1. Clear? These are the probabilities. The probability of an event is lies between 0 and 1, including 0 and 1. So this is about what it is, the probability formula. Now we will discuss a few examples related to this probability. Yes, here is an example. A coin is tossed 1000 times with the following frequencies. Here frequencies are nothing but outcomes. So head appeared 455 times out of 1000 times tossing the coin, and tail it is 545 times appeared. Now compute the probability for each event. Compute the probability for each event. Here what are the two events? Getting head is one event, getting tail is an event. It means find the probability of getting a head, find the probability of getting a tail. Here two events are there. You represent those two events with the two letters. Let H and T are events represents events representing getting a tail, getting a head on getting a tail, respectively. Right, now what is the formula to find probability of an event? E is equals to number of favorable outcomes of an event divided by total number of possible outcomes of an experiment that is symbolically n of E divided by n of S, where E stands for event. But here the event we have represented, getting head we have represented with the H, and getting tail we have represented with the T. Now here you find n of H is equals to, that is number of favorable outcomes of getting a head. Number of favorable outcomes of getting a head is 455. Similarly, number of favorable outcomes of getting a tail, that is n of T is equals to 505. Now find the probability of each event. Here the event is getting head, the other one is getting a tail. That is P of H is equals to n of H divided by n of S. That is n of H is equals to 455 divided by n of S, that is total sample space. If you divide this total sample space, n of S, all possible outcomes, it is 1000. Yes, 455 by 1000. So what we get? We are dividing with 1000. Therefore, the decimal point will move 3 digits. So decimal point will come after 4 left side. That is 0.455. 4, 5, 5. Now, P of t is equals to, that is n of t divided by n of s. That is probability of getting a tail is equals to number of favorable outcomes of getting a tail to the total number of possible outcomes of that experiment. Is equals to n of t is equals to 545, n of s is equals to 1000. 545 divided by 1000 we get 0.45. Yes. Now by adding these two, what we get? P of h plus P of t. P of t is equals to what we get by adding these two? Yes, by adding these two, what we get? 5 plus 5, 10. 4, 5 plus 4, 9, 9 plus 1, 10. 4 plus 5, 9, 9 plus 1, 10. And it is 1. So what we get? 1.000, that is 1. So probabilities, sum of all the probabilities of an experiment, sum of all probabilities of all events of an experiment is always 1. This is always 1. Like this we will find the probabilities of events in an experiment. Is it clear, children? Yes. So we will discuss in the next class some more some more examples.